Hi, my name's James. I've got another invention to post. I call it a slalom high performance suspension system designed for making your car uh, counter the body roll whenever you're cornering. So I'll show you what I've got. First, I'll show you an older design that I did a couple days ago, and then I redesigned it. So the new design is better. Got rid of some weight. This is the older design from a couple days ago. And here you can see uh, this area here is hydraulic fluid. This is hydraulic fluid, and you've got ports that allow you to transfer the vehicle weight from one side to the other to counter body roll beside your normal, strut action that you have going on here. It's got a nitrogen charged chamber for the fluid, and this one here I did kind of a standard design with your baffle, valving here in this piston connected to this rod to this body that allows your suspension, to move up and down, but still, meters the flow of the fluid. But what I changed is I got rid of this piston and rod and incorporated this valving into this piston here. So I'll flip this over. The wind's blowing a little bit, so I might tape this down. I put a little bit of tape on it. Anyway, so this is my revised version, Slalom High Performance Suspension Strut System. I'm designing a rack and pinion that will control it and self-center it. So whenever you turn, like this one is designed for 1 inch plus or minus, or 2 inches total vehicle anti-roll, control. So countering body roll by 2 inches total, leaning into a corner by 1 inch either way, or coming up 1 inch and down 1 inch on the other side. So 2 inches of total anti-body roll. But anyway, I incorporated the valving into the end of the control rod, and just like the other one, you see I have the fluid in the ports. I calculated fluid transfer on this size and this design. If you transfer the fluid back and forth at the top from full lean one way to the other, you would be transferring 20.36 cubic inches roughly of fluid. If you transfer at the bottom, depending on your application and the pressures and what's convenient for you, transferring at the bottom, the same stroke you get out of 11.30976 cubic inches. Now, if you're going to transfer the body roll with a pump or the rack that I'm designing from the bottom section, then the top section would free flow from one side to the other, or vice versa. If you're going to transfer from the top to control the body roll, then the bottom side would transfer from the left strut to the right strut, and vice versa. But anyway, as you compress this guy, your fluid transfers into the rod, pushing this piston down against the nitrogen charge. increases your spring rate. And this design right here, going from fully extended to full compression, it would change your nitrogen pressure by 58%. So you have a 58% spring rate over a 6-inch stroke. So, for instance, if fully extended, you charged this to where you had 1,000 pounds of load carrying capacity, say for, you would end up with 1,580 pounds compressed. So you would charge it to that capacity, say, if you were putting it on the corner of a car that weighed about 1,200 pounds on that corner. So that you'd be about a third of the way into the stroke. About 2 inches out of 6. So you have 6 inches of stroke, but you also have the plus or minus. So you have a total maximum extended value 8 inches greater than your maximum collapsed and leaning in value. It's pretty simple. I drew it up here with just a welded in end cap, but here's the thread in sealed, to help make it easier to rebuild, and plus, your Schrader valve for charging it, and a sealed cap plug to prevent leakage out of this Schrader valve, so you don't lose pressure over time or anything. All these little black dots or O-rings are representative of them. This is your position with 0.4 inch fluid clearance at fully extended. At fully compressed, this would be the piston position, and this fluid would push up to that point, compressing the nitrogen charge more. Your baffling is free-flowing between the center chamber and this section. This fluid to flow through here has to go through your valving, causing your variable amounts of resistance, at different compression speeds. And then, when it's extending, when you're compressing, your fluid is flowing through outer ports. You would have, say, maybe 4 ports coming into here and 4 ports coming from the outside, but offset. So it's pretty simple design, but I want $1 million for this. I need to get lots of other things that I designed manufactured, and I want to start a manufacturing business this is inventions number 89 and 91. I'll sell them together. They're basically the same thing, but I'll sell the 2 designs together for $1 million. Here's specs on this one. Pretty easy to tailor it to the vehicle weight. So super universal, and this system here could work on a small car. It can be also upsized to increase the stroke, just lengthening the rod and in this cross section here to increase stroke, and plenty of carrying capacity for a 1-ton truck down to a small light little car. And for this to work right, it comes down to proper ratios, size ratios and everything, so you're not having to use extreme amounts of piston travel, and you can modify the diameters a little bit to increase or decrease your spring rate. But anyway, my name's James Richard Stewart Jr. It's March 6th. So this here I'd signed and dated yesterday, but I revised it today, made a lot of improvements. I took out a piston out of the design, changed things up that ended up giving me another inch of stroke for the same length of body. So anyway, hopefully this video uploads okay. And anyway, I'm gonna upload this now. So my number is 907-347-6212. Give me a call if you have any questions. And yes, I already have the rack designed in my head that will control this and be self-centering. So have a good day, everybody.